Orders of magnitude. The order of magnitude of a number gives a rough idea of its size. It allows for a rapid comparison of numbers. This is very valuable when determining if an answer is reasonable. If a result is the same order of magnitude as what was expected, that makes it plausible that a hypothesis may be correct. When one number is 3 orders of magnitude larger than another, it's about 1,000 times larger. That will often be enough information to make a judgment about the reasonableness of an answer. To calculate a number's order of magnitude, first write it in scientific notation so you have a coefficient and a power of 10. Then eliminate the coefficient and round to the nearest power of 10. Increase the exponent by 1 if the coefficient is greater than or equal to 5, or leave it as it is if the coefficient is less than 5. The order of magnitude is the resulting exponent. Find the order of magnitude of these numbers. All right, so first we rewrite it in scientific notation. Then we just get rid of the coefficient. Now this coefficient is greater than 5, so this is going to round up. So we get rid of that, but then the exponent becomes a 4. 10 to the 4th, therefore the order of magnitude is 4. For 20,000, we put it in scientific notation, and then 2 is the coefficient. It's less than 5, so we're not going to round this up. We're just going to get rid of that, and our answer is 10 to the 4th, giving us an order of magnitude of 4. Note that these numbers right here, 8304 and 20,000, look very different, but they are the same order of magnitude since they both round to 10,000. On the last slide, I said both of these round to 10,000, and you might be like, wait, how does 20,000 round to 10,000? But basically, you're rounding to powers of 10. So it's either going to be 10,000 or 100,000. So we're saying 20,000 is closer to 10,000 than 100,000. All right, over here, put it in scientific notation. This is not greater than 5. We're not going to round. We're just going to get rid of it, and we have 10 to the negative 5th. Therefore, the order of magnitude is negative 5. The first two numbers are the same order of magnitude, but the last is 9 orders of magnitude smaller. Find the order of magnitude of these numbers. All right, so here we're going to put it in scientific notation, so we're going to move the decimal over 2. 3.72, and I'm just going to round it there, times 10 to the, all right, so we had to move it to the left 2, so we have a power of 2. 3 is less than 5, just get rid of it. 10 to the second, order of magnitude is 2. All right, next, put this in scientific notation. So 1, 2, 3, 4. 7.53 times 10 to the negative 4. Remember, it's less than 1, so we're going to have a negative exponent. 7 is greater than 5. So we are going to get rid of that, but then we're going to round this up. Now, to round it up, we actually decrease the exponent by 1 because this is a bigger number than this is. So the answer is negative 3. So just keep in mind, 7.53 is greater than 5. So this is going to round up. The order of magnitude increases from negative 4 to negative 3. It does not become negative 5 because that's smaller. All right, here's our decimal. We're going to move it 1, 2, 3, 4, 5, 6, 7, 8. 8.13 times 10 to the 8th. 8 is greater than 5, so we're going to get rid of this, round it up. The answer is 9. And there you have it, all the answers. The world population in 1950 was 2,556,053,053. What was the order of magnitude of the population? First, we put this in scientific notation. So we have to move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9 places. 2.556 times 10 to the 9th. Since 2 is less than 5, we're going to just get rid of the coefficient, and we're left with 10 to the 9th. Therefore, the order of magnitude is 9. The U.S. national debt in 1950 was $257,357,352,351. What was its order of magnitude? First, we put this into scientific notation. So the decimal's here, so we have to move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So we move the decimal there, 2.57, times 10 to the 11th. And since 2 is less than 5, we just get rid of the coefficient, and we have our answer, 10 to the 11th. Therefore, the order of magnitude is 11.